Hi everyone, Dr. Wallace here. Back to do another question from Alex. So this one's about graphing a rational function, and students usually get most of this right, but always forget the last step. So it turns out that this function here will have a hole in its graph, and it actually doesn't look like the graph of something like this. It looks like the graph of something different, but just with a hole in it. And we'll see that that's because the domain, well, let's just say it this way. A rational function is of the form p of x over q of x, where p and q are both polynomials. And it has a domain given by all real numbers x, so that q of x is not 0, right? So the places where the denominator is 0 are places where the function is undefined, obviously. So to figure that out here, I'm going to first notice that in this case, let's put that in a cloud. In this case, we can actually factor the top and bottom, and there are factors in common. So if I factor the numerator, I pull out a 3. If I factor the denominator, I can factor it into two parts, x minus 5 times x minus 2. Note that those will cancel out everywhere except for 5. Okay, so it equals the rational function 3 over x minus 2 if x is not equal to 5, and it's undefined when x equals 5, because that makes the denominator and the numerator 0. So this is going to mean there's a hole in the graph. Okay, so let's recall then how to graph a rational function that looks like this, 3 over x minus 2. Well, it has a vertical asymptote when x equals 2. Okay, so 1, 2, 3, 4, something like that. Okay, and the horizontal asymptote is what's the trend of the graph as x gets really, really big. Well, that's as x gets really, really big, the denominator goes to infinity, the numerator stays 3. So that's going to be, I don't know why I'm doing these in blue, but that means that here, because the degree of the denominator is larger than the degree of the numerator, I have a horizontal asymptote, y equals 0. And so to graph it, basically I just need to find two other points on either side of the vertical asymptote, and essentially draw a curve that goes close to each asymptote but doesn't cross them. So if I let x equal, say, 4, no, x equal 5 is better, right? So there's 5. If x equals 5, the denominator is 3 and the numerator is 3, so x equals 5, right? So we get that 5, comma 1 is on the graph. 1, 2, 3, 4, 5, and 1, so put a dot there. If I try, say, x equals -1, then the function value is also -1, right? Because I do a 3 on top and a -3 on bottom. I just pick those so that I have nice grid points here. So I have there. But we could have used Alex to basically put any ordered pair we wanted to there, so long as it's rational. And then to draw the graph, kind of go through this thing. Now on Alex, you would just hit the Graph Me button, and it would look something like that. Okay, this is approximate, of course, but that's not right, because when x equals 5, it's undefined, right? So there's actually not a point there. There is a hole. Okay, you might have to graph another point. So not a hole, so this is a hole on the graph. If I pick another one, say 4 and then 3/2, that is a point on the graph, okay? 4 and then 1.5 would be right about there, okay? So the thing that people forget usually is to place the hole in the graph. So don't do that. And make this so that this is actually correct. Is a point on the graph. So I hope that helps. Once again, now if you have a graphing calculator, you can always check your work. So let's go ahead and check to make sure that it looks like it should. So if I go y equals, let's clear out my old stuff here, put 3x minus 15 in parentheses, then divide that by, put the original equation just in case you made a mistake in some of your arithmetic or algebra before you started finding asymptotes. So we want to see if it basically looks like our graph we have here. So my window, let's do the standard window, -10, 10 by 1s, and -10, 10 by 1s. Okay, graph. There, that looks pretty much right. Now if you can't tell that there's a hole there, but if I go to second table, notice that when I put in 2, I can't put in 2 because that's a vertical asymptote. When I put in 5, that's an error. That's because there's a hole there. It's not in the domain. All right, so thanks for watching, and I hope you're getting ready for the last part of the semester.